Hello and welcome to my science tutorials. In today's video, we want to look at how to calculate the equation of a straight line when you are given only one point. Alright, so let's go ahead and look at how we do that. So assuming let's say we have our axis over here. So this is my x-axis, this is my y-axis, and I have, let's say, a straight line over here. And I only know one point, let's say x and y, and I don't know any other point on this straight line, but I know the gradient to be, let's say, m. How do I find the equation of this particular straight line? Now there are two ways you can do that. You can first of all use the equation of a straight line formula, then get that, which is y is equal to ms plus c. This is the equation of a straight line. So from here, all you do is you substitute the values of x and y into this equation to find the c, which is the constant. So your y is your y coordinate, your x is your x coordinate, your m is your gradient or slope, your c is your constant, or the point at which the line cuts the y-axis. Right, so in the first case, if you are using this formula, you only substitute the value of x and y into this equation to find a constant, and then you substitute it back to find the equation of the straight line. Or another way you can find the equation of a straight line is to use the equation y minus y1 equals m into bracket x minus x1. Over here, your point become x1, y1. So you substitute the value of x in place of x1, y in place of y1. You already know the gradient. You substitute that, and then you do your calculation to get your equation of that particular straight line. Alright, so let's go ahead and look at an example. So we have to find the equation of a straight line with gradient 2 through the point 0, -5. Right, so I'll be using the 2 method in this case. So let me write down my solution. So I've been told that my gradient m is 2 and my point is 0, -5. Now when I'm using the equation of a straight line, y is equal to mx plus c, the first thing I need to do is to calculate the value of my constant, or c. I do that by substituting. This is x, this is y. So I substitute this into the equation. So I have -5 is equal to m, which is 2, multiplied by x, which is 0, plus c. So I have -5 is equal to, this is 0, 2 multiplied by 0 is 0, plus c. So therefore it means that c is equal to -5. From here, it therefore means that the equation of my straight line is equal to y is equal to my m, which is the gradient, is 2, s, my constant is 5, so -5. So this becomes my equation of the straight line. Alright, so let me use the other formula, which is y minus y1 is equal to m into bracket x minus x1. So from here, I have this become my x1 and y1. So I write y minus y1 is -5 is equal to the gradient, which is 2, multiplied by x minus x1, which is 0. So I have here y plus 5 is equal to 2, then multiplied by x, since this is 0. So I have y plus 5 is equal to 2x, and I can rewrite this as y is equal to 2x minus 5. So this becomes my equation of the straight line. Now if you see, you can see that these two equations are the same. So whether you decide to use the values to calculate the constant first and substitute it back into the expression to get the equation of the line, or you use the direct method where you just substitute your value and get your equation, you will get the same answer. Alright, so let's have a look at another example. We have to find the equation of a line with the gradient 3, which passes through the point 2 and -4. So let's write down our solution. Okay, so let me say case 1 or approach 1, and then case 2 for us. You can use any of them. So in this one, I'm going to use y is equal to mx plus c. I know that from this point I have 2, -4. So this is my x, this is my y. My y here is -4 is equal to my gradient m is 3 multiplied by x, which is 2 plus c. So I have -4 is equal to 6 plus c. -4, I bring the 6 to the other side, minus 6 is equal to c, and therefore my c is equal to -10. So I can now substitute that back into the equation. So my equation will now be y is equal to my m, which is the gradient, 3x, and my constant c is -10, so it becomes -10. So this becomes my equation of the straight line. In the second case, we have y minus y1 is equal to m into bracket x minus x1. So my y1 in this case is -4, so I have -4 is equal to my gradient, which is 3s minus x1, which is 2 over here, so I have 2. So this is y plus 4 is equal to 3 multiplied by s will give me 3s, 3 multiplied by -2 will give me -6. So I have y is equal to 3s minus 6. Then I send a positive 4 to the other side of the equal to sign, it becomes -4. So -4 here. So I have y is equal to 3s minus 6 minus 4 will give me -10. So this become my equation of the straight line. And as usual, they are the same over here. Alright, so let's go ahead and try one final example. You can go ahead, pause this video, try your hands on this problem to see if you can get the equation of a straight line. Alright, so let's go ahead and look at the solution to this problem. So we have to find the equation of a straight line with the gradient 2, which means our gradient is 2 through the point 4 and 3. Alright, so for this case, I'm just going to straight ahead use the second method. So y minus y1 is equal to m into bracket x minus x1. So from here, all I need to do is to substitute my values. So I have y minus, my y1 is 3 into bracket m, which is 2 into bracket x minus my x1 is 4. So over here, I have y minus 3 is equal to, I expand this bracket, I have 2x minus 8. From here, I maintain my y here is equal to 2x minus 8. Then I send the -3 to the other side, it becomes plus 3. So my y is equal to 2x minus 8 plus 3 will give me -5. So this is -5. And this becomes my equation of that particular straight line. So thank you so much for watching, and I will see you in the next video, where we'll be talking about how to find the equation of a straight line when you are given 2 points on that particular line. So thank you once again for watching, and I will see you in the next video. Bye bye. Hello and welcome to my science tutorials. In today's video, we want to look at how to calculate the equation of a straight line given 2 points. Alright, so let's look at the diagram we have over here. So we have a straight line having the first point having the coordinate x1, y1, and then the second point B with the coordinate s2, y2. Now, if we are asked to find the equation of this straight line, we can use the equation or the expression y minus y1 equals m into bracket x minus x1 to get the equation of this straight line in the form y is equal to ms plus a constant c. Now, if you look at this expression, you realize that we have y1, x1, which we can obtain from the first point with the coordinate x1, y1. But we do not know the m, which is the gradient or the slope of this line. So the first thing we do when we have a straight line having 2 points to find its equation the first thing we need to find is to calculate the gradient of the line, which can be found by subtracting y2 minus y1 on s2 minus x1. So if you use this in calculating the gradient, the value you obtain over here, you substitute that value into the expression y minus y1 equals, then you have that value over here, which is the gradient, s minus x1. Already you have your x1 and y1 here, so you substitute them over here respectively, and then you find your equation of that particular straight line. Alright, so let's go ahead and have a look at an example to understand and appreciate what we are talking about. So we have to find the equation of a line joining 2 points, 2, 4, 1, 4. One point is 2, 4, and another point is 5, 3. So let's write down our solution. So I will say let A be the first point, which is 2, 4, and B be the second point, which is 5 and 3. Alright, so like I said, the first thing we need to do is to calculate the gradient of this particular 2 points before we use them in finding the equation of the line joining these 2 points A and B. Alright, so to do that, I'll first of all label my coordinates. So this is my x1, my y1, this is my s2, my y2. My gradient now is equal to y2 minus y1 on s2 minus x1. So this is equal to my y2 is 3 minus y1, which is 4, on my s2, which is 5, minus my x1, which is 2. So over here, my gradient is equal to 3 minus 4 will give me a negative 1, and 5 minus 2 will give me 3. So my gradient is negative 1 on 3. Alright, so substituting the gradient m into the equation y minus y1 equals m into bracket x minus x1, I can now go ahead and find the equation of my line joining these 2 points. So I have here y minus my y1 is 4 over here, so I use that, is equal to my gradient negative 1 on 3 into bracket x minus my x1 over here is positive 2. Alright, so all I need to do is to simplify this expression to get my equation of the straight line. So I have a fraction here, I need to get rid of it, so I use 3 to multiply each term over here. So I have 3 multiplied by y minus 4 is equal to 3 multiplied by negative 1 on 3, then x minus 2. So if I expand this, I have 3y minus 12 is equal to, this will cancel this, so I'm left with negative 1 into bracket s minus 2. Alright, so from here I have 3y minus 12 is equal to negative 1 multiplied by s will give me negative x. Negative 1 multiplied by negative 2 will give me a positive 2. So I can rewrite my equation as 3y is equal to negative x plus 2 plus 12. So I have 3y is equal to negative s plus 14. And this becomes my equation of a straight line. Now, if you like, you can rearrange this. Okay, you can rearrange this and have 3y is equal to 14 minus x. Or if you like, you can bring everything to this side, which will become 3y minus 14 plus x is equal to 0. You can rearrange it how you want, but they all mean the same thing, and they are all the equation of the straight line having the 2 points, this and this. Alright, so let's have a look at another example. We have to find the equation of the line AB in each of the following cases. In case 1, we have the point A with the coordinates 2, negative 1, and the point B with the coordinates 3 and 0. In the second case, we have A with the coordinates 3, 5, and B with the coordinates 5, negative 1. Alright, so let's go ahead and look at the solution for this problem. So for the first example, we have A 2, negative 1 as its coordinates, B having 3 and 0. This is my x1, my y1, my s2, my y2. So I first of all need to find the gradient, which is y2 minus y1 on s2 minus x1. This is equal to my y2 is 0 minus my y1, which is negative 1, on my s2 is 3 minus my x1, which is 2. So I have over here negative minus 1 will give me positive 1, then 3 minus 2 will also give me 1, and this is equal to 1. So therefore I write down my expression y minus y1 is equal to m into bracket x minus x1 in order to find the equation of my line AB. I do the necessary substitution, that is y minus y1, which is negative 1, is equal to 1 as the gradient, and x minus s1 is 2 over here. So I have here y plus 1 is equal to s minus 2, and this therefore I'll continue here. So I have y is equal to s minus 2. I maintain this, then I bring the positive 1 to the other side, it becomes negative 1. So my equation of the straight line will now be equal to y is equal to s minus 3. So this becomes my equation of the straight line having the coordinates a and having the point A and B with the coordinates respectively. Alright, so let's look at the second aspect. So I have A with the coordinates 3 and 5, B with the coordinates 5, negative 1. Alright, so I label this x1, y1, s2, y2. As usual, because I'll be using this formula in finding the equation of the straight line, I need to calculate the gradient first. To do that, I have m, which is my gradient or slope, is equal to y2 minus y1 on s2 minus x1. This is equal to my y2 is negative 1 minus my y1 is 5 on my s2 is 5 minus my x1 is 3. So I have negative 6 here on 2, and this will give me a gradient of negative 3. Now substituting this into the expression, y minus y1 equals m into bracket x minus x1, I have y minus y1, which is 5, to be equal to negative 3 as the gradient, s minus x1, which is 3. So I simplify this expression to have my equation of the straight line. So I have y minus 5 is equal to minus 3s plus 9. Now I have y is equal to minus 3s plus 9. Then I send the negative 5 to the other side, it becomes plus 5. So I have y is equal to minus 3s plus 14 as my equation of the straight line. Alright, so thank you so much for watching. This is how we calculate the equation of a straight line when we are given 2 points on that particular line. So I'll see you in the next video where we'll be talking about the equation of the perpendicular bisector of a line. Thank you once again for watching, and I'll see you in the next video. Bye bye.